All right, on day 2 of 6.1, we covered these two types of problems. The first one is we have to be able to take something in a different form and get it into the form y equals your start value times either 1 plus or minus. This can be plus if it's increasing, minus if it's decreasing, r raised to the t. Because this r is your percent increase if that's 1 plus a rate, and if it's 1 minus that rate, then that's the percent decrease. So we need to be able to find out what that r value is. So to do that, we need to look at the given equation, and we have to be able to convert that. So when I look at this, I'm going to use the laws of exponents. So I'm going to rewrite this equation as a. A is just any number, so we can just leave the a in there. It's 0.5 raised to the t over 19 power, so I'm going to take that 1 over 19 and put it with the 0.5. So remember, laws of exponents say when you have a power to a power, you multiply the exponents. So I haven't changed anything. I still have a, and I have 0.5 raised to the, when I multiply those together, I would get t over 19 power. So this is equivalent to this. Now, why did I put it in this form? Because I want to get it into this form up here that is 1 plus something raised to the t, not to the t over 19. So now I have to figure out what is 0.5 raised to the 1 over 19 power. So on my calculator, I'm going to take 0.5, raise it to the, and again, some of you might have to put this in parentheses. Mine goes up to as an exponent, so I can just do 1 divided by 19. If yours doesn't raise to an exponent and just leaves that little caret button there, the caret button, then you have to put it in parentheses. So hit enter, and I get 0.9642. So this is equivalent to y equals a times 0.9642 raised to the t. So that's really my base when I try to put it in this form, but remember, to find the percent decrease or increase, we have to know what is the difference between that number and 1. So since it's smaller than 1, to find the percent decrease, I'm going to take my base, and I'm going to take 1 minus that base. That'll tell me what that percent decrease is. So if I take 1 minus my answer, I get y equals a, 1 minus 0.0358 to the t. So when I took 1 minus 0.9648, I got this number. So that's my percent decrease. So when it asks you what is the percent decrease, it's 3.58%. Remember, we have to move it 2 decimal places. That becomes 3.58%. So we have to rewrite it like this, using our laws of exponents, figure out what that decimal is, but then to find the percent decrease, I have to take 1 minus that base. That tells me my decimal as a percent, and then I have to move it 2 places. Okay, every one of those will be exactly the same. Find this number, then take the difference between 1 and that base. That tells you your percent decrease. All right, the last one is the compound interest. You will be given this formula, I believe. I'll double check that with the other teachers. But you're going to take your starting amount, we call that the principal, times 1 plus your rate as a decimal over n. N is the number of times it's going to be compounded in a year, raised to the nt. T is the number of years. So in this problem, I started out with $7,900. 1 plus the rate, it says 1.29%. So if I move that 2 places, I get 0.0129. It is compounded quarterly, so that means 4 times a year. So n is 4. So I'm going to raise that to the n, which is 4, times t, the number of years, which is 5. So I'm really going to raise it to the 20th power. Okay, so this is my starting amount, times 1 plus the rate as a decimal over the number of times it's compounded per year. So if it's monthly, it's 12. Yearly, it's 1. If it's compounded semi-annually, that's twice a year, so n is 2. If it's daily, that would be 365 times a year. So this is the number of times it's compounded in a given year. T is the number of years. Once you have those things filled in, just use your calculator. So I'll put that over here. So on your calculator, there, you're going to type in 7,900, parentheses, you can type it in just as is, 1 plus 0.0129 divided by 4. The calculator will do order of operations. It'll divide this first, then add the 1, and because that's in parentheses, it'll get that answer before it does anything else. Then you want to raise it to the 4 times 5 power, or just raise it to the 20th power. Hit enter, the calculator will do the correct order of operations. I get $8,425.47. That's the amount I would have after 5 years, $8,425.40. It does round to 47 cents because this is a 6, but it rounds up because of that digit right there. It's bigger than, it's 5 or greater. So that's the amount I have. So again, it's the start value here. The percent goes in as R, but as a decimal. N is the number of times it's compounded in a year, and T is the number of years. So you just fill those things in, and then just throw that in your calculator to get your answer. Label it in dollars, because that's how many dollars you would have if you started out with this amount for 5 years at compounded 4 times a year at 1.29%. You would have at the end of 5 years $8,425.47. So in day 2, those are the 2 kinds of problems we covered. Compound interest, knowing what those letters all mean and how to plug it into an equation to solve, and ones where we have to convert from one form to the other. So when they give it to you in this form, you know how to get that decimal, and then once you have that base, you know to find the percent decrease, you subtract it from 1 to get your percent decrease. So those were the 2 new kinds of problems we covered in day 2.